This tutorial is about number systems. There are many number systems. One that is popular and used daily in our everyday lives is the decimal number system. The decimal number system is based on 10 digits. The digits in the decimal number systems are as follows: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. For example, the decimal number 4,185 represents a value equal to 4 thousands, plus 100, plus 8 tens, plus 5 ones. The thousands, hundreds, tens, and ones are powers of 10, insinuated by coefficients positionally. The decimal number 4,185 can be represented a different way. I have it broken out so you can see it. Here we got 4 times 10 to the third power. That's actually the value of 4,000. And then we got 1 times 10 to the second power, which is 100. And then we got 8 times 10 to the first power, which is 80. And then we got 5 times 10 to the 0 power. Remember, anything to the 0 power is 1, so we got 5 times 1, and that's pretty much the value 5. And that all adds up to 4,185. Below I have a general formula, and pretty much what it shows is you can see the coefficients, and the letter R is representing the base. In this case, it's base 10. And so when you add all that up, the general formula shows that it is a sequence of coefficients. And we can show in this case here, like A3 represents the digit 4. A2 represents the digit 1. A1 represents the digit 8. And A0 represents the digit 5. The decimal number system is considered to be base 10, and there are only 10 digits to use. There are different number systems used by the digital computer, such as binary, octal, and hexadecimal. The octal number system is considered to be base 8 because each coefficient in an octal number is multiplied by a power of 8. There are only 8 digits to use. The hexadecimal number system is considered to be base 16. Each coefficient in a hexadecimal number is multiplied by a power of 16. And there are only 16 digits to use. And the binary number system is considered to be base 2 because each coefficient in a binary number is multiplied by a power of 2. And there are only 2 digits to use. For example, the number 10.5 is a decimal equivalent of the binary number 01010.10. This can be described where each coefficient is multiplied by a power of 2. So let's show this. Let's see, we got it written out 01010.10. That's in binary form. And what we want to show is that each coefficient is multiplied by a power of 2. In this case here, we got this 0 is represented here. And so that's saying 0 times 2 to the 4th power. Anything times 0 is 0. Okay. And now we got the digit 1 multiplied by 2 to the 3rd power. That's saying that is in the 3rd position. So here we have 2 to the 3rd power is 8, so that's a value of 8. And then we have the 0 represented here. 0 times 2 to the 4th power, or 2 to the 2nd power, excuse me, is still 0. And then we have this coefficient here is represented here. 1 times 2 to the 1st power, and that's saying 1 times 2 is 2. And then we have that 0 is coefficient is represented there. It's 0 times 2 to the 0 power, and so that's saying 0. Then we have the 1, which is represented here, and this is a little different. That's because this is after the decimal point, and it's on the right side of it, so you're going to have negative exponents. So we got 1 times 2 to the minus 1, and this is the same thing as saying 1 times 1 over 2, which is 1/2, and so we can say that this is pretty much same thing as 0.5. And then we got the last coefficient is 0, which is represented over here to the far right, and that's pretty much 0. So when we add them all up, we pretty much got an 8, got a 2, and then we got a 0.5, and that equates to 10.5. The convention to distinguish between numbers from different bases is the fact that the coefficients are enclosed in parentheses, and a subscript is used to represent the base of the number system. So I'll try to indicate that here by putting in parentheses. Here we got coefficient is in parentheses, and here's the base, which is a subscript. So here's an example below. We got 10.5. This is represented in decimal format. And it is equal to its binary equivalent, which is on the right side here. This is binary. You can see the base 10 represent decimal, and base 2 represents binary. When describing a number system, we use the digits from the decimal number system when the base is smaller than 10. When the base of the number is greater than 10, the alphabets are used to represent the digits that have a value greater than 10. For example, the digits used in the binary and octal number system are as follows. So binary, we only have 2 to play with. We only got a 0 and a 1. Those are the only 2 digits that you could use in a binary number system. Octal, we have 8 digits. That's 0 through 7. The digits in the hexadecimal number system are as follows. We have 16 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And when we get to 10, you can't represent that because the decimal only have 0 and 9 digits. So we have to replace that with letters. So here in this case, we got the letter A represents the value 10. B represents the value 11. C represents the value 12. D represents the value 13. E represents the value 14. And F represents the value 15. So we got an example here of a hexadecimal value. We got A54E. This is a hexadecimal base, which is base 16. So I broke it down just to show how you take that hexadecimal value and convert that to a decimal value. For example, is 10 times 16 to the 3rd power here. We have a value of like 40,000. It's 960. And then the 5 times 16 to the 2nd power, and you multiply that out, that's 12 180. And then when you multiply 4 times 16 to the first power, it's pretty much 64. And of course, you're multiplying 14 because we said here we got the letter E is representing 14. Also, I meant to identify that A is representing 10 here, so that's why we're using 10 here. So E is representing the value 14. So we got 14 times 16 to the 0 power. That's the same thing as saying 14 times 1, so just 14. It's here. And that comes out to be a value of 42,318. And that is represented as a decimal value. So during my next tutorial, I will describe terms involved in math operations. I hope this tutorial has been helpful. If you find this tutorial to be helpful, please subscribe to my YouTube channel by clicking the subscribe link above. Also, feel free to join us at the computing sector. There will be more videos and tutorials coming soon. Thanks.